Ladies and gentlemen, welcome back to my YouTube channel. I take this opportunity to appreciate you. And let's continue with our enlightenment in biology. Today I'm presenting classification 2, and specifically I want to look at the organism known as amoeba in detail. So I want to look at the animal known as amoeba in detail. Did you know amoeba doesn't just move? It can reshape its entire body to engulf food. Stick around to see how this incredible process works. Have you ever wondered how tiny single-celled organisms like amoeba manage to eat without a mouth? In this video, we'll explore the fascinating world of Amoeba Proteus, its unique feeding process, and what its marvel of microscopic life. Stay tuned as we dive into the biology of one of nature's simplest yet most intriguing creatures. I will expound this organism by first of all looking at a question which was set in KCSE 1994, question 12, and it was on the structured part of the paper. So the question started this way. Below is a diagram of an organism. So that is the organism which was shown. All right. That's the organism shown. Magnified 300 times. Amoeba Proteus. So what did the examination council want? They wanted you to name the phylum to which the organism belongs. Number Roman 2a, give a reason for your answer in what you have said above. Number B, outline the process by which the food particles get into the organism. And number C, what happens to the food particle eventually. So let's see how the mark scheme was. In the marking scheme, Roman 1, the phylum to which the organism belongs is Protozoa. And the council was not accepting protozoan, so that one was rejected. The reason was it is single-celled animal. You can just say single-celled. Or unicellular animal. You are supposed to reject organelles that may be mentioned. So if any organelle is mentioned, you don't give a mark. Outline the process by which the food particles get into the organism. Council wanted you to mention phagocytosis and maybe explain that pseudopodia extended to surround the food particle Membrane pinches off from the cell membrane to form food vacuum. You are supposed to accept by phagocytosis to form food vacuum. Also accept engulf for extend to surround. What happens to the food particle eventually? The council wanted you to say the food is digested by secretion of enzymes into the food vacuum. The digested soluble food material is absorbed, and by exocytosis of indigestive material. That involves merging of vacuum membrane with the cell membrane, releasing the indigestive materials. Accept type of enzyme. Now, we are over with what the council tested that year on classification 2. Now, on my part, I've decided to even make you understand much details of this organism. And I'm beginning by the taxonomic classification of Amoeba Proteus. So the domain is Eukarya. All right. Kingdom is Protista. Phylum is Amoebozoa. Class is Tuberinia. Order is Eumwebida. Family is Amoebidae, and the genus is Amoeba, so that the species becomes Amoeba Proteus. In summary, I've tried to summarize the questions of the examination council. And I've just said that the phylum is Protozoa, and the reason is the organism is unicellular and exhibits locomotion using pseudopodia, which are characteristic of protozoans such as Amoeba. So I expound. Okay? Unicellular, then I talk about pseudopodia, and you see, in the summary, I'm trying to elaborate further. Process of food intake is known as phagocytosis, and there are 3 things which happen here. The pseudopodia extended to surround the food particle. The food particle is enclosed within a membrane, forming a food vacuum. Digestive enzymes are secreted in the food vacuum to break down the food. Then what happens to the food particle eventually? The digested food is absorbed into the cytoplasm for use in various metabolic processes. Any undigested material is expelled from the organism by exocytosis. Guys, we cannot end the discussion of amoeba just like that. Why don't we look at the ecological significance of Amoeba Proteus? Number 1, nutrient cycling. Decomposer role. Amoeba Proteus feeds on dead organic matter and microorganisms, aiding in the decomposition process and recycling nutrients back into the ecosystem. Mineralization. By breaking down organic matter, it releases essential nutrients like nitrogen and phosphorus into the environment, supporting primary producers like algae. Maintaining microbial balance. Predator of microorganisms. Amoeba feeds on bacteria, algae, and smaller protists, helping to regulate the population of these organisms. This balance prevents overpopulation, which would otherwise disrupt the ecosystem. Food source, play for larger organisms. Amoeba serves as a food source for large microscopic organisms and small aquatic animals. It forms an important link in the food chain, transferring energy from microorganisms to higher trophic levels. Number 4, indicator of water quality. Amoeba Proteus thrives in unpolluted, oxygen-rich water. Its presence indicates a healthy aquatic environment, while its absence may signal water quality degradation. Research and education importance. As a model organism, Amoeba Proteus is widely studied to understand basic biological processes like cell movement, osmoregulation, and phagocytosis. This research can indirectly contribute to ecosystem conservation. In summary, Amoeba Proteus plays a crucial role in maintaining ecosystem stability, nutrient recycling, and supporting biodiversity within aquatic habitats. Thanks for joining us in unveiling the mysteries of the amoeba. Don't forget to like, comment, and subscribe for more deep dives into biology. Share this video with a friend who loves science, and let's keep exploring the unseen world together. My thanks goes to ChatGPT by OpenAI, assisted by NEC, where I got the question from. Goodbye, and see you in my next video.